Jai Hind. Today our topic of discussion is informed search. In informed search techniques, we'll talk about what informed search is, what is best first search family, and among this family we will discuss greedy best first and A star search, and then we will talk about the admissibility of heuristics and the algorithm. So informed search strategy. So what we need to know here is, when we are given some problem, in problem we will be given exactly what we need to do. If in addition to the problem we have some specific knowledge about the domain, then we can apply informed search strategies. So what does it mean? In addition to the actual problem definition, we are having some additional information. For example, if I have to go from one source to one destination, and I know that there are multiple paths, and what I need to find out, I need a solution which is having the best path. But if I have this knowledge that on weekend this particular route will be comparatively low loaded, low congested, it means I know something more than the problem. My problem was to drive from source to destination, but now I'm having some additional information that on weekdays on weekdays on a particular route the congestion will be more in comparison to weekend days. So that is the point, that we are having some extra knowledge in addition to the problem. So when we use these problem specific knowledge for any particular problem, then we can find the solutions more efficiently. So these are our informed search techniques. When we do not have any additional information about any problem, then we use uninformed search techniques, which we call blind search. So in accordance to that, we search blindly, but now we are having some additional information, so we are able to find the solution more efficiently. Now the main thing is, what is the approach to use the informed search techniques? What is the approach to use this problem specific knowledge? So general approach is best first search. So now in this particular lecture, we'll talk about our best first search techniques. So when we talk about best first search technique, the idea is we will use an evaluation function Fn. The evaluation function will tell us that which is a better node for expansion. So it is used for selecting a node for expansion. So how do we define it? It is actually defined according to our desirability. It is an estimate of desirability. For example, I want to count when I want to go from source to destination, and I want to know the distance in kilometers. So my estimate will be the lesser number of kilometers if possible on a particular path. So what we do, we will use the evaluation function and we will expand most desirable unexpanded node. What does it mean? It means if I start from a point and I know what are the nearby cities to reach to the destination D, so I'm having the options to go towards the neighboring cities. I can go through this route or this route or this route, but when I will expand S, so currently I'm at S, that is my starting state. After that, I will choose the next state, and now the point is, from these next state, which should be expanded further. So that is the problem here, that is solved with help of evaluation function. So when we implement best first search, we use priority queue. Queue we know, first in first out. In queue we are having the concept of which is entered first will be executed first. But in priority queue, what we use, we will maintain the fringe in ascending order of f values. What is my f value? That is my evaluation function value. So each of the neighboring states will have a f value associated, f1, f2 and f3. So this is our desirability of this state, f1, desirability of this state. So we will expand which is most desirable one. This is the idea for best first search. When we talk about these type of search technique, best first type of search techniques in which we use the evaluation function, so we are having a number of algorithm existing that we call family of best first search algorithm with different evaluation function. So what evaluation function we take, it depends on that what the name will be. So what is the key component to these particular algorithm? That is the heuristic function HN. Heuristic is regarding what information you are having. So what is the key component here? That is heuristic function. What the heuristic function defines? Heuristic function Hn, n is our node. Heuristic function Hn gives us the estimated cost of the cheapest path from node n to our goal. Let me call goal is G. Okay. So what it takes the estimated cost of the cheapest path from node n to goal node G. So if we are calculating the heuristic function and we are at goal itself, then Hn will become 0 because that is the estimated cost. So what is the main point to be remembered here? It is the estimated cost. It is not true cost. It is our estimation when we are at node n, that how much cost I have to pay to reach to the goal node G. Okay. So now what we talked about initially, that we will discuss some algorithm for this informed search. So we are taking here two algorithms from best first search techniques. First one is greedy and second one is A star. So when I am saying that it is a family of best first search, so now it will depend on Hn, that what function I am taking Hn, and based on Hn what function I am taking as Fn. Okay, so let us discuss both the methods one by one. So first one is greedy best first. My first method is greedy best first search. So from the name it is clear that we are using the greedy approach. The greedy programming we will use here to find out the best path. So we are trying to find the best path using using the criteria that we are greedy here. Greedy here means at node n. When I am at node n, I will take the greedy approach. Greedy approach means whatever will seems to be good now, that simply I will take. So my evaluation function will be totally based on Hn. My Fn will be Hn. Hn is my heuristic function. And as we have discussed on last slide also, what is Hn? It is estimate of cost from n to goal. Estimate of cost from n to goal. For example, if I am standing here and I'm talking about some nearby city, Delhi or Meerut, I'm simply saying, if I talk about Meerut, that it is 50 kilometers from here. So that is my estimate. Okay. So that estimate I'll take here as evaluation function. This is our greedy best first. Means whenever we are at node, we will try to find out the further estimate and which node we will expand. We will expand that node which will give me the minimum cost. One example of heuristic is HSLD. SLD stands here for straight line distance from n to Bucharest. Now let me explain here that what type of problem I'm going to take. I'm going to take, for example, in this particular lecture, the Romania map, where I have to go from my current city Arad to Bucharest. So this is my source and this is my destination. I'll take the map on further slides. And so what I said, when I'm taking some heuristic, so one heuristic in this example, I will take HSLD. SLD is for straight line distance. What is the straight line distance from n to Bucharest? Bucharest is my destination. And as I told, what greedy best first search do, it expands the node that appears to be closest to the goal. It will be the node which is really looking closer to the goal. So we will expand that particular. So we are greedy in expanding that. We will expand that particular node which is seemingly closer in comparison to others towards the goal. So that is our greedy best first search. So let us understand with an example. So this on this particular slide, this I have taken the Romania map. So what actually I want to do, I want to start from Arad and want to reach to Bucharest. So let me take this as my source and this as destination. So the map I have taken from the textbook only, and my aim is to find the best path from Arad to Bucharest. If I start from Arad, we can see from map that it is having 3 neighboring cities, Sibiu, Timisoara and Zerinde. So if I see these neighboring cities 1 to 3, I am given here the path from Arad to Sibiu, it is 140 kilometers, Arad to Zerinde it is 75, and here it is 118. Okay, so what is given? The direct distance from these cities. So I will go towards some city from here, and then by driving through other intermediate city, my final aim is to reach at the destination, that is the city Bucharest. So that is our problem. So we are having from starting 3 options. Okay, so this is our cost from moving from Arad to Sibiu. This is cost from Arad to Timisoara, and so on. We can view from this particular map. Now what else we are going to take here, that is the heuristic. In heuristic, what we have taken, straight line distance to Bucharest, as we said on the previous slide that we can have number of heuristics. So we have taken the straight line distance. So what is given on this particular slide, from Arad Bucharest in straight line is at 366 kilometer distance. From Bucharest to Bucharest, the straight line distance is 0. And let us talk about the 3 neighbors. The 3 neighbors, immediate neighbor cities of Arad was Sibiu at 253, Zerinde at 374, and Timisoara is at 329 kilometers. So this is a given map to us, some information is given. So from Arad, when we will start, we'll take one among these cities, and then further we will see what are the neighboring city of Zerinde, what are the neighboring city of Timisoara, and what are neighboring cities of Sibiu. So we have we need to finally reach to the destination with a good path according to this. So now what we are having, we are taking the greedy approach. So let us start, let us understand with an example now. So what is the situation? I am at Arad and I need to reach to Bucharest. So my problem is to find out the solution using greedy best first. So what I am trying to do, I am trying to find out best first, I am trying to find the best path which is available, but with my greedy nature. So later I will see ki am I able to find the best path or not using this greedy approach. So first point is, when we solve a problem using searching, so first point is we start from initial state. Now my initial state is Arad. I will expand it if it is not goal node. What is my goal node? My goal node is Bucharest. So because it is Arad, not Bucharest, so it means I have not yet the final state. So I need to explore it, and then I will move towards the destination, toward the goal state using greedy best first search. So when I will start from Arad, now I am having the straight line distance, and as we have seen on the last slide, that 366. Now because we are having only one node, so we need to expand it. So what are the neighbors? Neighbors are Sibiu, Timisoara and Zerinde. We have seen on the last slide that from Sibiu, the straight line distance to Bucharest is 253, 329 from Timisoara and 374 from Zerinde. Now what the point is, we are greedy in approach. When we are able to see here that Sibiu is having only 253 straight line distance to destination, that is Bucharest. So I am greedy in selecting this, that I will go via this path. So I have selected it for the next expansion. So that is Sibiu. So what I am going to expand now, that is Sibiu. So after expanding Sibiu, what I found that from Sibiu the neighbors are Arad, this we already know, and other neighbor cities are Făgăraș, Oradea and Râmnicu Vilți. Now what the point is, the straight line distance we have taken from the slides previous, that is given on this one. So from here we have taken the straight line distances. So after taking these straight line distances, we are able to see that from Arad, the straight line distance is 360c. From Figueres to Bucharest, it is 176. Oradia 380, Reminiscence, it is 193. Now again we are greedy when we know that from Figueres it seems to be 176. So we have selected Figueres here for expansion. So from Arad we have reached to Sibiu, and now from Sibiu we will expand Figueres. So now Figueres we will expand. Now what we are getting from Figueres, again Figueres neighbors are Sibiu as we have already seen, and the second one is Bucharest. Now when we will see the straight line distance from the HSLD table, I found that Sibiu it is 253 SLD from Sibiu to Bucharest and 0 from Bucharest to Bucharest. So what is the minimum value? That is 0. So we selected Bucharest, and it will pass the goal test because it is the goal. So we have seen here that the goal state is reached. So this path we have found. This is our greedy best first search example. So we have moved from Arad to Bucharest by exploring, by expanding the path which seems to be closer to the destination in our given heuristic. The heuristic we have taken, that is straight line distance. So this is our greedy best first search example. So we have talked about the greedy best first search. What we are having in this, the evaluation function we have taken same as the heuristic function. Same as the heuristic function. Now the properties of greedy best first. Is it complete? That is the first question. Greedy best first search doesn't give us the guarantee that it will be complete, because we can have in some map some loop. That is a closed cycle. It means I am going from here to here, then to this, and back to the original position from where I was moving on this cycle. So what I did, I started from A, went to C, then went to B, and finally again came to. So it may be the case that I get stuck here. Why? Because I am greedy in exploring the nodes which I am exploring, which is having the minimum value. So if I say ki among A, for A I am getting this small path, smallest path, from C this smallest path, and again from B this smallest path. So as it is greedy in selecting the smallest path, so it may be the case that it go on moving from A to C to B to A to C and so on. It may get stuck in this loop. So the greedy best first is not complete. The time and space complexity both are exponential in nature, and it depends on the improvement. We can improve this time complexity, but that depends on the heuristic, what heuristic we are taken. After this we will talk about types of heuristic also. So a good heuristic can make the improvement, but in general it is exponential, b to the power m. And because we are expanding the nodes and all the neighbors are kept in memory, so the space complexity is also b to the power m, because all nodes are to be kept in memory until we reach to the destination. It is not optimal. The greedy best first search is not optimal because it is greedy in further path. It is not taking in account the previous traveled path that we have already paid, the amount that the cost that we have paid to reach to n. What I want to say that if I am starting from starting state S and I need to reach to destination D, and there are so many nodes in some intermediate cities. So let me take a node N, which is an intermediate city. So when I take this example, what greedy best first is doing, it is simply checking the best path from N to D. It is ignoring this previous cost of reaching from starting to N. So it may give us the best solution or may not be. So we cannot say it is optimal one, because it is greedy about the rest amount to be paid, the rest cost to be paid. So these are the properties of greedy best first. So the second method from best first search techniques are is A star search. In A star search, what we do, we try to solve that problem that we faced in greedy best first. What I talked about, that when it starts from S, reaches to D via N. Now what we want to consider this cost also. Let me take the example that I started from a RAD, I drive to a particular city. So let me say I have already covered some X kilometer. And now from N I am taking the best path, that is my HSLD, that is only the estimated best, estimated cost. So now if we consider this also along with that what is the point? We avoid expanding paths that are already expensive. It means we are not greedy from N only. We are seeing that what is X kilometer, have we paid already a long cost, a big cost. If we have already paid, then we will ignore that path. We will not see only the HSLD. That is the idea behind A star search. So what is done here? The evaluation function is improved to include that. Improved means Fn is Hn as in previous, plus it is taking the value Gn. So let us understand, Gn is this cost and Hn is this cost. So what is Gn? When I started from starting state S and reached to N, so I have already covered X kilometers. So that is my cost paid, which I have already paid, that is Gn. And this is my estimate that how many more kilometers I need to move. Or if I take the metric as time, then I can say that 1 hour I have already paid. Okay, I have gone, I have moved from S, that is start, to some intermediate node, and further I am having the estimate that it will take 1 more hour. So that is my estimate. So what is evaluation function? The evaluation function is Gn plus Hn. Gn is the cost so far to reach N, that is the actual cost. To reach up to N, that is the actual cost. And what is Hn? Hn is the estimated cost from N to goal. Further I am having only estimate. So main point to be noted, when I am at this level N, this cost I have already paid, this cost, and this I am just having estimate. So that what is my evaluation function? My evaluation function is Gn plus Hn. What is Gn? Cost so far to reach N, and what is Hn? Estimated cost from N to goal. So what if I am having my now Fn, that is the evaluation function, is estimated total cost of path through N to goal. It is not N to goal, it is not estimate from N to goal. Now it is the estimated total cost of path through N to goal. It means total estimate from here to here. In this, part is actual and part is estimated. So this is our concept of A star search. Now let us understand this with the same example. We need to move from Arad to Bucharest. Arad is my initial state and I need to reach to the goal, that is Bucharest. So what is Arad here? The initial state. Is it goal? No. So definitely it will be expanded because it is the only possible node here. Now see what we will do here. What is the distance from HLD distance from here to Bucharest? That is 366. And what is the cost paid from Arad to Arad? That is definitely 0. So total cost here we are getting is 366. Okay, so we will explore it. This is the only one, only state, and which is not yet the reached goal. These are the neighbor states, Sibiu, Timisoara and Zrin. Now see what we did in greedy best first. We took the HN, means SLD 253, from Timisoara 329 and from Zrin 374. But here in this we are taking the actual cost also. What is the actual cost paid from Arad to Sibiu? It means from Arad, when I will move to Sibiu by driving, I have to cover 140 of the kilometers. So when I will cover, when I have already covered 140 kilometers, further what is my estimate? That is 253. So total is 83. Same way from Timisoara, it is 118 plus 329, that is 447. And from Zarind, 75 kilometers is the distance from Arad to Zarind, and 374 is the estimate from Zarind to Bucharest. So total is 449. Now what is minimum among these? That is Sibiu. So it is not greedy best. In this we have covered, we have added the cover distance also, the true cost. So here we are using the true cost, and here we are using the estimate. So this is our A star search example. So now what will be solved here, what will be expanded, that is Sibiu. From Sibiu we are having 4 neighbors: Arad, Fagares, Oradia and Riminici. We'll see. Now what the point is, when we talked about Arad, from Sibiu to Arad distance is 280, and from Arad HSLD is 366. We already know that. Same from Fagares, 239 and 176. Now when we take all these calculation, we find 646, 415, 674 and 413. So, and the two which we have already expanded, Timisoara and Zarind, has 447 and 449. So among all the expanded, among all the generated nodes that we are having on our fringe, okay, what we are implementing? Priority queue. So which we will take, that is showing us the best path. Which is showing us the best path? 413 cost. So that is Riminici, we'll see. So what we will expand next, that is this particular node. This is our A star approach. We are using the already covered path, means this is the already covered path plus the estimate, that is HSLD 193. Okay, so what path we are getting here, that is 413. So we will expand this particular node. After expanding this node, we are getting further neighbors of Riminici, we'll see, that is Crevia, Pitesti and Sibiu. Now when we explore these, we find cost 526, 417, 553. Now among all the existing nodes on the fringe, now there is no node in this particular, no sitting which is having the minimum value. Which is having the minimum value? That is Fagares, 415. 415 is the minimum value here, that is we have found, that is present on our fringe till now. So we will exclude that, and what we will take here, we will take for expansion the next node, that is Fagares. So this is our next node to be expanded. So after expanding Fagares to its neighboring nodes, we are getting values 591 and 450. How we are doing it? We are taking Fn as Gn plus Hn. Gn is the actual cost and Hn is the SLD estimate, straight line distance estimate. Okay, now all the nodes on fringe are present, which are Arad, Oradia, Sibiu, Bucharest and all. But what is the minimum? This is priority queue. What is the minimum among that? That will be taken. What is the minimum one? This one, 417, Pitesti. So this will be explored next. Next, which node will be expanded? The neighbors of this particular node will be cross-checked. Okay. So now it has been generated. What has been generated? The neighbors of Pitesti, that is Bucharest, Crevia and Riminici, will see. So now when we see this, now what is the minimum among these? That is 418. When we see that it is 418 and it is Bucharest, now it is minimum one as well as it is the goal node. It is passing the goal node. So it will be taken and it will be the terminating criteria because it is fulfilling the goal node. So this is Bucharest. We have reached. So this is the path that we have covered. So this is our A star algorithm. In greedy best first, we have taken Fn as only Hn, that is the heuristic, and in this we have taken Fn is equal to Gn plus Hn. Gn is the actual cost to come to n, and then Hn is further estimate from n to the goal node. Now one more point to be noted in this informed search technique, that is admissibility. admissible heuristic. A heuristic Hn is admissible if for every node n, Hn is less than equal to H star n. What is H star n here? That is the true cost. When we have to go from source to destination, definitely it will have a true cost. So that true cost we are taking at H star n. The heuristic, we can take anything as heuristic, but the heuristic which is always less than equal to the true cost, that is admissible heuristic. For example, the heuristic that we have taken, what we have taken? SLD, straight line distance. If we take two cities, source and destination, then SLD will be straight line distance. It will be lesser than all the possible paths, the roads constructed, flyovers constructed, and whatever is there. It will always be lesser than that. So it will be HSLD will be the admissible heuristic. So now the main point is A star optimal? That is our problem. That is the point to be noted here. If Hn is admissible, then A star search using tree search will be optimal, definitely. So in greedy best first we have we have studied that that is not optimal, but A star is optimal provided your heuristic is admissible. One more point, the properties. What are properties of A star? It is complete as well as optimal, and it is exponential as greedy best first. Exponential in time as well as in space. All the nodes need to be kept in memory, but that was not complete and optimal. But A star is complete and optimal provided your heuristic that is considered is the considered heuristic is admissible. If we are having two heuristics, H2 and Hn, and both are admissible, it means both are less than the true cost. If H2n is greater than H1n for all n, both are admissible, then we say that H2 dominates H1. So which one we should take? If we are having two heuristics, which one we should take? Which is dominating the other one. So H2 is better for search. So linear, how we find out that which one is better? So that just learned by the experience. Directly we cannot say that this one is better than that one. So what we can do, if we are having a class, a problem, there we can think of different heuristic, but we need to take that heuristic, we need to consider that heuristic that is having greater value than the other one. So in this lecture we have talked about informed search techniques, mainly best first family. From there we have discussed greedy best first search and A star. Thank you. Jai Hind.